Happy International Astrology Day or Happy Equinox. Now, the spherical Earth model has a problem here that they cannot account for on the days of the equinox. The inclinational tilt of the globe Earth model cannot account for this, and it basically debunks the globe model itself on the equinox days. Especially, it's more pronounced for those that are living on the equator, looking at the sunrise and the sunsets on these sacred special days. The equinoxes are celebrated around the world and they have great cultural significance. In the north, this day signals the long-awaited end of winter, while in the south, it marks the arrival of autumn. So people in the northern extremity experience the spring or the vernal equinox in March and the fall or the autumnal equinox in September. And in the southern extremity, it's just mirror opposite. The seasons are reversed. The equinox dates are March 21st and September 21st. And in my opinion, I think that this should be basic knowledge that everyone has at any given time. So for those who are not familiar with this phenomena, let's review the equinox in relation to the figure 8 analemma that indicates the 4 cardinal points on the calendar.
23.5 degrees above the equator, we have a tropic. Okay, that's the Tropic of Cancer. That's the Tropic of Capricorn. And I'm going to do that sine wave. You will have seen it if you've got a globe of the Earth, and some of them still have this sine wave. You'll see from the Tropic of Cancer to the Tropic of Capricorn, you'll see a sine wave that goes right around 360 degrees around you. This is the basis for everything, guys. And this sine wave is just a pulse of energy. It's electric. It starts with Aries over here on the 21st of March. It's an electric pulse. March 21st, the equinox. Equal day, equal night, because equinox means in Latin equal night. And it only happens twice. Over here, 6 months later in September, the 21st. Some people put the 22nd or the 23rd, okay? That date there is a little bit different to the others. June the 21st, the solstice, the longest day of the year, and then when the sun hits Capricorn, it's December the 21st. That's the day the sun dies. The sun is the hero. The sun gives us an electric pulse in summer, and then it gives us a magnetic pulse in winter. The sun gives us photosynthesis, then it lets us be buried in snow. Okay, it's the springtime. Spring, summer, autumn, winter. I'll put winter back over here too so we can see it going around this way, but if you have a linear graph it will go like that, but a circular graph will come around. So we've got spring, summer, autumn and winter. When the sun climbs up 23.5 degrees up to the Tropic of Cancer, that's midsummer. If you're in Italy, you're going to be on the beach. If you're down in Australia over here, it's freezing when the sun is on June the 21st. It's midwinter, but up there it's summer. So let's look at this from the north, okay? And then we will understand the whole science. So June the 21st is the solstice. Solstice, sol is the sun. Stitio means stand still. Why? Because the sun, as I said before, it travels 47 degrees on the horizon. That's 47 degrees from there to there. So you'll see the sun go from summer, autumn, winter, spring, summer, autumn, winter, spring. As it hits the solstices, it appears to stop. The sun, you can watch it on the horizon. You can watch the sun go from summer to winter, whether you watch it rising or whether you watch it setting. You'll see this. It's always moving. It's walking on the water. When it sets on the water, it walks on the water. 47 degrees every year. When it's rising in the east, it rises, comes up out of the ocean. You see the fire coming up out of the ocean. All sacred scriptures, all of them, they're all sealed with 7 seals, 7 levels of interpretation. The highest one is this, which I'm about to show you, because this leads to the mystical.
International Astrology Day. It's a very specific day, spring equinox. It's the beginning of the astrological natal chart, as it were, so it makes perfect sense that it would be International Astrology Day. Astrology is so deep in knowledge. It goes back thousands and thousands and thousands of years. It just goes back virtually to the beginning of time. And life itself would not have been created without numbers and energy and electromagnetism, and that is precisely what astrology is. It is electromagnetism, connecting terra firma to the ethereal realm. It's like a little ongoing connection of electronic energy. We are, of course, electric, so we're part of the whole gig. So this is why I find astrology just absolutely fascinating, mind-blowing, and the reason why it's so accurate is because it is so numerically based. It's pure numerics measured in degrees, minutes, and seconds.
In the Northern Hemisphere, we have now reached the spring equinox, an annual solar event where day and night are of equal length, and the sun will rise at its most easterly position and set at its most westerly position. In fact, the very name of equinox comes from the Latin words of equi, meaning equal, and nox, meaning night. The spring equinox is an event that has been celebrated by ancient civilizations for thousands of years, and there are a number of sacred sites that align to the equinox, pointing towards its use as another ancient calendar marker for crop rotations. It was also a time to honour fertility, celebrating the rebirth and renewal of the land and animals. In neo-pagan cultures, the spring equinox is known as Ostada, a name given to it after the Germanic pagan goddess of the spring and the dawn, Eoster. However, there is very little mention of her before the 7th century, and scholars and historians alike have disputed her existence in pagan worship. The spring equinox is a time to celebrate the rebirth of the natural world, to bask in the growing warmth from the sun, and to notice the subtle changes in the landscape around us that show that the quickening of the year is now in full force.
Now, according to heliocentrism, our planet's axis of rotation is tilted at 23.5 degrees at all times. This means that the Earth's northern and southern extremities receive unequal amounts of sunlight during most of the year, depending on which location you are at, in relation to where your location is, either pointing towards the sun or away from the sun. And this axial tilt is the reason for the seasons on the ball model. And this axial tilt remains permanently fixed at all times. It never changes. Okay, but on the day of the equinox, when you observe the motion of the sun, if you're on the equator, it's equal. So there is no elliptical motion or anything like that. The sun rises directly due east, goes straight up above you, maintains that equal trajectory all day long, and then sets due west in a straight line. There is no deviation from that on the day of the equinox. Any accurate model will depict this for you. And so the equinox definition, according to your basic heliocentric supported website like starwalk.space.com, for example, will tell you that an equinox is a moment of time when the Earth's axis is tilted neither toward the sun or away from the sun, making day and night almost equal across the world. But that's a problem because there's always a tilt in the heliocentric globe ball model. At an equinox, people in both the southern and the northern parts of the world experience an almost equal duration of daylight and nighttime, about 12 hours. So no matter where you are in the world, the due east and due west points on your horizon mark the intersection of the celestial equator with the horizon. On the day of the equinox, the sun is positioned right on the celestial equator. And for this reason, the sun rises due east and sets due west on the day of the equinox. Now, in the heliocentric model, the equinoxes are presented in a way that requires the removal of the Earth's axial tilt when demonstrating sunrises and sunsets. To align with observational data, the globe must be positioned upright, eliminating the 23.5 degree inclination that is central to the heliocentric paradigm. When you look at website images, they show the Earth straight up and down. And furthermore, when calculating sunrise and sunset angles, the globe model is forced to projecting a flat plane of Earth to measure these angles accurately. This fact aligns with the geocentric perspective, where the sun's motion is mapped against a stationary Earth rather than relying on axial tilt and orbital mechanics of the heliocentric hypothesis. Even official diagrams, websites, and educational resources depict the sun emerging from and setting into a flat plane, further reinforcing the inconsistency of the globe model. So what is effectively being presented is a flat Earth imposed onto the side of a sphere, contradicting the fundamental heliocentric premise. The very need to nullify the axial tilt during equinox demonstration underscores the flaw in the rotating globe model of the heliocentric hypothesis. On the equinox, a due east sunrise and a due west sunset should not be possible if the Earth remained tilted as claimed in the heliocentric hypothesis. The need of standing the sphere upright in models exposes the inherent contradictions within the heliocentric explanations. Models such as the Andrew Marsh model and other proponents of the standard ball model make these adjustments, conveniently disregarding the axial tilt to make the system appear functional. This type of modification is consistent with other instances in which scientific models require fudging the data to maintain their coherence with the globe ball model. Therefore, when analyzed critically, the equinox observations align more naturally with the geocentric framework, where the sun moves relative to an immovable Earth rather than the Earth tilting and orbiting around the sun. The equinox presents an insurmountable inconsistency for the heliocentric model, revealing the necessity of altering foundational claims to maintain its coherence. The axial tilt, which is supposedly constant and fundamental to the ball-Earth model, must be effectively nullified in order to align with observed equinox phenomena. This contradiction is not merely an oversight, it's an unavoidable flaw in the globe paradigm that requires modification of the model itself to appear functional. In contrast, the geocentric perspective offers a more direct and observationally consistent explanation. The uniform motion of the sun on the equinox, its direct overhead path for those on the equator, and its precise alignment with due east and due west sunrises and sunsets all align with the stationary Earth framework. The necessity of projecting a flat plane onto a globe to calculate equinox-related angles further reinforces this reality, as even official astronomical resources depict a geocentric construct when illustrating these celestial events. Therefore, a critical examination of the equinox, independent of preconceived heliocentric assumptions, strongly suggests that the sun's motion is best understood with the geocentric framework. The persistent need to adjust the ball's model, the tilt of the Earth, to accommodate observed equinox phenomena is not a mere technical simplification. It's an admission that the model itself fails to naturally account for one of the most significant celestial events experienced worldwide.